Hello, mathletes. My dog Finley is going to be in the video today. We are doing unit or topic 8, which is all about right triangles, and we're going to introduce trigonometry, which is super fun. So 8.1 is just a nice little review of right triangles and the Pythagorean theorem, but we're also going to introduce these new things and new characteristics of our 45, 45, 90 triangles. Right, so right triangles that have two 45-degree angles and a 30, 60, 90, so a right triangle that has 30 and 60-degree angles. New vocabulary, we're going to look at what is a Pythagorean triple. And then we're also going to look at and do a quick review of the Pythagorean theorem, and then we're going to look at here at these 45, 45, 90s and 30, 60, 90s. So let's go ahead and go to the back of our packet where we have our vocabulary and theorems, and let's review some of these. Okay, so here we have our terms. Our only new term that we're going to look at today is my computer's moving. There we go. Our Pythagorean triples. These are our three natural numbers or positive numbers that work in the Pythagorean theorem, right? Which is a squared plus b squared equals c squared. So any three numbers that make this equation true are considered a Pythagorean triple. There are special ones that come up quite often. And so if you see them, then you automatically know that you're dealing with a right triangle. For example, if you have a triangle with side lengths 3 and 4 as the legs, and a hypotenuse is 5, you automatically know that that's a right triangle. And it doesn't have to just be 3, 4, 5. It can be multiples of 3, 4, 5. So it can be 6, 8, 10, right? If I multiply them all by 2. Or if I multiply them all by 3, it could be 9, 12, 15, right? So it can be multiples of those numbers as well. Another one that comes up often is if I have a triangle with legs of 5 and 12 and a hypotenuse of 13, then it is automatically a right triangle. And again, it can be multiples of those numbers. So 10, 24, 26 would work as well. Okay, but realistically, any three numbers that work in this equation are a Pythagorean triple. These are just some common ones that we see. Let's then go down to our theorems and review the Pythagorean theorem and a couple others. Okay, so the first one, a quick review of the Pythagorean theorem. In a right triangle, it has to be a right triangle. The sum of the squares of the legs is equal to the hypotenuse squared. So here's my right triangle. And the angles aren't labeled, but this would be A, this would be B, and this would be C, right? So remember that we use capital letters for angles and lowercase letters for sides. So Pythagorean theorem is a squared plus b squared equals c squared. And it's always leg squared plus leg squared equals the hypotenuse squared. So the longest length, the side across from the right triangle, or from the right angle, that is always your hypotenuse. So whatever the longest length is your hypotenuse. Whatever the side length is across from the 90-degree angle is the hypotenuse. Okay, the next one here, so we have two special right triangles that we look at. The first special right triangle is a 45, 45, 90-degree triangle. So this is a triangle that's a right triangle because I have the 90 degrees. And then the other two angles are both 45. So they're, the remaining 90 degrees is split in half. This triangle will always follow this pattern where the two legs are always the same. So x and x. And the hypotenuse is always whatever x is times the square root of 2. And that's just a pattern that always happens. When you have a 45, 45, 90 triangle, your two legs are always the same length, and your hypotenuse is going to be whatever that leg length is, times the square root of 2. In a 30, 60, 90 triangle, similar idea in that every single 30, 60, 90 triangle that you see will have a pattern, right? Whatever leg is next to the 60 degrees is going to be your x. Okay? To get the hypotenuse, you take that value and you multiply it by 2. So this will be 2 times x. And then to find the longer leg, the leg that's next to the 30 degrees, you take your x and you multiply it by square root of 3. And it's always just going to be that same pattern over and over and over again. So what we're going to do today is we are going to review Pythagorean's theorem. And so we'll do a couple problems reviewing that. And then we'll look at how do we solve these 45, 45, 90s or 30, 60, 90 triangles. So let's go back to 8.1 and look at Pythagorean's theorem first. Okay, so here we are back at 8.1. Let's look at example 1 is just using the Pythagorean's theorem. Okay, so example 1 says, find the length of A to B, right? Well, AB is across from the right angle, so this is the hypotenuse. And that's important to note because remember that in my Pythagorean's theorem, A squared plus B squared equals C squared. The C is always the hypotenuse. The A and B are interchangeable. It doesn't matter as much. But the C always has to be the hypotenuse. So we can fill this in. Let's say A is 15. So my leg length there is 15. Plus B is my other leg, which is 12. And then this equals, and I don't know what C is, so I'm going to just leave it C squared. Okay. Once we start solving, 15 squared is 225, plus 12 squared is 144, and that equals C squared. Add them together, and I get 369 equals C squared. Now, when I want to get rid of the squared, right, I don't want C squared as my answer, I want C. So to get rid of that, I need to take the square root of both sides. So I get that the square root of 369 equals C. Okay. And that's great, but it's not what we call simplified or reduced, right? I need to reduce this radical or simplify the radical by doing a factor tree. So we got to think back to our time learning how to do a factor tree, where I'm just looking for two numbers, any two numbers that multiply to 369. And I know that 3 goes into this, so I'm going to divide it by 3. 369 divided by 3 is 123. 3 doesn't break up any further, but 123 does. That is 3 times 41. And what I'm looking for is a pair of numbers. And so here is my pair of numbers. So that means I can take one of those out. So I can take 1, 3 outside of the square root. And the only number that's left is 41. So that number stays underneath, right? Once you break a number down, you don't need it anymore. So the only number left is 41. So the length of AB in simplified form is 3 square root of 4. Wow, I put 14, I said 4. Both are wrong. It's the square root of 41. And there's the length. Okay, go ahead and pause the video. I want you to try this next one. Again, keeping in mind, what information are you given? Are you given both legs? Are you given a hypotenuse, right? So just make sure that we're filling in the numbers in the correct spot. So go ahead and hit pause, and then when you're ready to go over it, hit play. Okay, so when I look at my triangle here, here's my right angle at angle F. My 10 is across from that. So 10 is my hypotenuse. That means I'm going to plug in 10 for C. Okay, 10 is not a leg. 10 is the hypotenuse. 7 is a leg. So that can either be A or B. It doesn't matter. But 10 has to be C. So I'm just going to let A be 7. Doesn't matter. So 7 is one of my legs. I do not know the other leg, but I do know that my hypotenuse is 10. So if you place these incorrectly into the equation, just know that whatever's across from the right angle has to always be the hypotenuse. Okay, so 7 squared is 49 plus b squared equals 10 squared is 100. I'm going to subtract 49 to both sides, right? Minus 49, minus 49. And I get b squared equals 51. Now I'm going to want to take the square root, right? So b is equal to the square root of 51. So now I need to check, can I simplify the square root of 51? So I'm going to do my factor tree. 51 splits, it's 3 times 17. 3 doesn't split anymore because it's prime. Neither does 17, it can't split down. So since there's no pair of numbers, I can't simplify the square root of 51. So that just tells me that the length of EF is just the square root of 51. And there it is. Let's look at another example of using the Pythagorean theorem. Nice little review. Okay, A says, to satisfy safety regulations, the distance from the wall to the base of the ladder should be at least 1/4 the length of the ladder. Did Drew set up the ladder correctly? So whatever the length is of the ladder divided by 4 is the smallest distance I can have between the wall and the base of the ladder. Right? If I go any smaller, that ladder will be too vertical and it could risk falling over. So one, I need to know the length of the ladder. And I know it's kind of hard to see on your notes, so if you feel like you want to redraw it, that's fine. Where this is 2.5 and this is 9. And then here's the 90-degree angle. So I want to find the length of the ladder. So a squared plus b squared equals c squared. 2.5 is a leg, right? It's not across from the right angle. 9 is also a leg. So I can just fill those in for a and b however I'd like. So I'm going to say a is 2.5. But it doesn't matter. Sorry. So I'm going to plug in 2.5 for a, but you also could have plugged in 9 for a, and it doesn't matter. Okay. And so since I did 2.5 for A, I'm going to do 9 for B. And then I'm trying to solve for C. 2.5 squared is 6.25. Plus 9 squared is 81. Equals C squared. We're just combining like terms, so we're going to add them together. 87.25 equals C squared. But I want C, not C squared, so I'm going to take the square root. So I get the square root of 87.25 equals C. Now, because this is a decimal, we don't need to try to do a factor tree here. We can just go ahead and enter it into our calculator. And I get C is approximately 9.34. So that is the length of the ladder, 9.34. I know that's like really hard to see. I guess I could do it here instead and it'd be easier, 9.34. Okay, so by safety regulations, whatever that length is, which in this case is 9.34, times 1/4 is the minimum distance that the ladder can be from the wall. Well, multiplying something by 1/4 is just the same thing as dividing it by 4. So I'm going to divide 9.34 divided by 4, and I get approximately 2.33 feet. So 2.33 feet is the minimum distance that this ladder can be from the wall. If it's any closer than 2.33 feet, um, it's unsafe because the ladder's too vertical. The ladder's currently at 2.5 feet, so since 2.5 is greater than 2.33, right? So the ladder is set up correctly. It's fine. 2.33 is the smallest it can be, but it's currently set at bigger than that. So we're good to go. Let's look at part B here. I'm going to scroll down a little bit. Part B says the length of each cross piece of the fence is 10 feet. Why would a rancher build this fence with the measurements shown? So if we kind of take this fence and maybe just look at one triangle on the fence, right? This is 6, this is 8, and this is 10. So why specifically would a rancher build a fence with these dimensions? Okay, so the first thing that kind of sticks out is that this is what we just talked about with the Pythagorean triple. If I were to divide each of these numbers by 2, I would have a 3, 4, 5 triangle. So we can say since 6, 8, and 10 is a Pythagorean theorem, not theorem, holy moly, you guys, is a Pythagorean triple, this is a right triangle. So that tells me that this is a right triangle. That tells me that this is 90 degrees, and then this is also 90 degrees. So why would a rancher want the vertical posts of his fence to be 90 degrees? Well, if we think about it, right, a vertical, where am I? There we go. Vertical to the ground, or vertical posts, if they're perpendicular to the ground, if they cross the ground at 90 degrees, that's their most stable position. If they're leaning a little bit, they're more likely to fall over. Okay, so the posts, let's just say the vertical posts, are perpendicular to the ground. So what does that mean since they're perpendicular to ground? It means that they're more sturdy. So when a rancher is building his fence, he wants it to be sturdy, right? So he wants those vertical posts to be perpendicular to the ground. So let's look at a couple try-its that I want you guys to try, and then we'll go over them. So the first one here says, what is KL? So it just wants what is this length. So we have to figure out, is it A, B, or C, right? So here's the Pythagorean theorem, a squared plus b squared equals c squared. So you have to figure out which of these values am I given, which one am I trying to find. And then part B, it's asking, is this a right triangle? So I need to know, do these three numbers fit in a Pythagorean theorem, right? If I were to plug them in, would they work? and make sure that you are plugging in your angles correctly. So go ahead and give these two a try. So pause the video, and then when you're ready to go over it, hit play and we'll review them. Okay, so hopefully you've paused it, you've tried it, now we're coming back. Remember that whatever side is across from the 90 degrees is going to be your C. So these can be A and B interchangeably, but KL is my C. So I'm going to just plug in my values. I'm going to call A 9, but you could call A 40. It doesn't matter. So B is 40 equals C squared, and I'm just solving for C. 9 squared is 81. 40 squared is 1600 equals C squared. If I add them together, I get 1681 equals C squared. And I want to take the square root of both sides, right? So the square root of 1681 equals C. So I enter that into my calculator, and I get that the length of KL is 41, and I have units here, so it's centimeters. 41 centimeters. So the square root of 1681 is 41. Then for B, I'm just seeing, is this a right triangle? Does it work? Okay, so the only thing I have to keep in mind, and whatever my longest length is, that is always C. C is always the longest side. So again, it doesn't matter, 35 and 12 are interchangeable, but C is not interchangeable. C has to be 37. Okay, so I'm going to say 35 squared plus 12 squared equals 37 squared. 35 squared is 1225. 12 squared is 144. And 37 squared is 1369. I'm going to add these two numbers together, and I get 1369 equals 1369. So then the question is, does it work? And yeah, right? The left side equals the right side, so we're good. So yes, triangle MNO is a right triangle. And there we are. One more, try it here. So I'm going to scroll down a little bit. One more, try it right here. Okay, to meet safety requirements, a wheelchair ramp must have no more than 1 foot of unit rise over 12 units of length. So we're talking about centimeters here. So it can only, along 12 centimeters, it can only go up 1 centimeter. And then the next 12 centimeters, right? It can go up 1 centimeter longer than 12 centimeters, but that's the minimum, okay? 11 centimeters, it can't go up a full centimeter. It has to be 12 or bigger. So this says, does this ramp show meet the requirements? Well, I don't know how long this ramp is. I know it goes up 41 centimeters, but I don't know how long it is. So we're going to have to find the length of this ramp. So go ahead and use Pythagorean's theorem and find the length of the ramp, and then we'll go over the second half of it together. Okay, so hopefully we've given it a shot by now. Here's my Pythagorean's theorem. And again, I have to be very conscious of what values am I given and what values can I plug in, okay? So here, my 500 is across from the 90 degrees, so that's C. 41 can be either A or B. It doesn't matter. So I'm going to call 41 B for no reason, just because I'm choosing to. Equals, and C is 500. Okay, so I have A squared. 41 squared is 1681. And 500 squared is 250,000. I'm going to subtract 1681, right, to both sides. which leaves me a squared equals 248,319. And then take the square root, and let's just round to the nearest whole number just to make our lives a little bit easier. We get about 498 centimeters. So the length here is 498 centimeters. Okay, so over 498 centimeters, it goes up 41 centimeters. So I need to make sure, right, that it doesn't, that each centimeter of increasing is 12 centimeters or more of forward movement on the ramp. Okay, so what we're going to do is we're going to take my length of the ramp and we're going to divide it by the height. This will tell us how long each increase of 1 is. And I'm going to again use approximates because I'm rounding. I get about 12.1 centimeters. So every 12.1 centimeters, I go up 1 centimeter. And then the next 12.1 centimeters, I go up 1 centimeter, right? And so the minimum is 12, so does 12.1 work? Yes, right? I'm allowed to have that. So 12.1 is greater than 12. So the ramp meets the requirements. So what we're looking at here is that whenever we have some sort of word problem, we usually want some sort of sentence answer. So 12.1 is greater than 12, therefore the ramp meets the necessary requirements. Okay, moving on, we're actually going to skip example 3 and then just go straight to the try it. The only thing is I'm just going to remind you in a 45, 45, 90 triangle. So we're switching now to looking at those special right triangles, 45, 45, 90, and 30, 60, 90. So in a 45, 45, 90, my two legs are always the same length, whatever it is. If this is 4, this is 4. This is 15, this is 15, okay, whatever it is. And then my hypotenuse is always whatever that side length is times the square root of 2. So if this is 4 and 4, this would be 4 square root of 2. This is 15 and 15, this would be 15 square root of 2. And it's just that pattern over and over and over again. So I want you to try this first one real quick. Find the side lengths of xz. So what is the length of xz? And what is the length of yz? So go ahead and pause the video, give it a quick try, and then when you're ready, hit play and we'll go over it. Okay, so here I'm given my 45, 45, 90. This is my hypotenuse, right? Because it's across from the 90 degrees. So this is my other leg. XZ is my other leg. Well, my two legs are always the same, so XZ will have to be 7 units because it is the same length as the first leg, right? Both legs are always the same. So that has to be 7. And then YZ is the hypotenuse. Well, following the problem, the two legs are always the same. And then the hypotenuse is whatever the leg is times square root of 2. So it will be 7 times square root of 2 units. And we just leave it like that. We don't have to write it in decimal form. There's no need to simplify it or anything like that. We just write 7 roots. Okay. One more for you to try here. I'm going to scroll down. Go ahead and pause the video here and see if you can figure out this one, and then we'll move on to 30, 60, 90 triangles. Okay, so this one's a little different. Notice that the only thing I know is that one, it's a 45, 45, 90, but I also know my hypotenuse, not my legs. But remember that the hypotenuse is always whatever my legs are times square root of 2. So in this case, my x is just 12, right? Because here's the square root of 2, here's 12. So that tells me that my legs are both 12. So JK is 12 units and LK is also 12 units. And that's it. Okay, now let's look at our 30, 60, 90 triangles. So I'm gonna kind of off to the side here, draw one of these guys for us to kind of remember. So if this is 60, this is 30. So again, whatever side, whatever leg is next to the 60 degrees, that's gonna be my X. If I multiply that by 2, that gets me the hypotenuse. And if I take that leg and multiply it by the square root of 3, that's the third side. Okay. So here in this example, my 60 degrees, right? This is X, this is 2X, and this is X square root of 3. So if I want to start plugging these in, I know that that RQ is 6. So PQ is this length here. I take my X value, which is 6, and plug it in right here. So PQ is 6 square root of 3 units. And then PR is 2 times X. Well, X is 6, right? So 2 times X is 12 units. So we're just using this pattern over and over and over again. Okay, I want you guys to try this. There's actually 2, so I'm going to erase this and scroll down. I want you to try both of these. So go ahead, pause the video, give it a shot, and then when you're ready, hit play and we'll go over it. Okay, so let's look at this first, try it. Again, remember, whatever, I'm just going to write the pattern down again. Whatever leg is on the 60 degrees is my X. Then the leg on the 30 degrees is X square root of 3. And then my hypotenuse is 2X. So using that pattern, I can find the length of UV and I can find the length of TV. So let's start with UV. I know that TU is 9 root 3. So that means that X has to be 9. So UV then has to be 9 units. I also know that my hypotenuse is always 2 times X. Well, if X is 9, then my hypotenuse has to be 18 units. And that's it. Okay. Let's look here at the next try it. It tells me that K to L is 180 units. Okay, so again, I'm going to write in the pattern. The leg with the 60 is X. The leg with the 30 is, I don't want to write it that close to it, is X square root of 3. And then the hypotenuse is 2X. Okay, so that means that 180 is 2 times something. Well, if I divide 180 by 2, I get 90. So that lets me know that the length of JK is 90 units. Right? Because it's 2 times, 180 is 2 times something. So then that should be pretty quick then to help me find JL, because X is 90. So JL is 90 square root of 3 units. And voila, there we are. Last example here, we're going to look at example 5 and how do we apply it. So let's look at these two. It says Alejandro needs to make both the horizontal and vertical supports, so AC and AB, for a ramp. Is a 12-foot board long enough for both supports? Explain. So again, this is a 30, 60, 90 triangle. So I'm going to write down the pattern. The leg with 60 is X. The leg with 30 is X square root of 3. And the hypotenuse is 2X. Okay, so this tells me that 2 times something is 10. So that tells me that x is 5 feet, which means that this length right here is 5 square root of 3 feet. And so I want to know, we can get rid of these now, I want to know if I add those two together, is 12 feet of wood going to be enough? Okay, so 5 plus 5 square root of 3, and I'm going to add those together. And using my, calculator for that square root of 3 part, I get 13.66 feet. So is a 12-foot board going to be long enough for both? And the answer is no, right? So a 12-foot board is not long enough because I need 3.66 feet. So 12 feet is not going to be enough. Okay. I'm going to get rid of this one, and so we can move down just a little bit. There we go. Part B here says Olivia starts an origami paper crane by making the 200 millimeter diagonal fold. So here it is right here. What are the side lengths and area of the paper square? Okay, so I'm just going to recreate one of these because it's those colors are really hard to see, right? So this is 45. This is 45, this is 90, this is S, which means this is also S, right? And the pattern, this would be S times the square root of 2. But I'm told that it's 200. So that tells me that whatever S square root of 2 is equal to 200, because that's what the actual length is. So I can divide both sides by square root of 2. The square root of 2 is just a number, right? So I can do that in my calculator. And I get about 141.4 millimeters. So that is the length of all four sides, because it is, when you're doing origami, you start with a square, right? A perfect square. And it tells me it's a square. So I know all four sides are 141.4. So what are the side lengths? Boom. There you go, side lengths. Then it says, what's the area? Well, area of a square is equal to base times height, right? Or the side times the side, or whatever. So in this case, the base is S and the height is S, right? It's a square, so they're the same length. So it's just going to be 141.4 times 141.4. And so I get that the area of this square is about 20,000 millimeters squared. And don't forget the squared part, right? When we're talking about area, we have to have this squared. And there it is in all its glory. 2 try-its here. And then we are done with this lesson. So our 2 try-its, find what is the length of AB? What is the length of BC? And again, if it helps you to write down the pattern, please do so. And then part B says, what is AC and what is BC? So go ahead and hit pause on the video, give it a try, and then when you're done, hit play and we'll look at it. Okay, so my first one on part A is a 30, 60, 90. So I'm gonna go ahead and kind of out to the side write the pattern, right? The leg with the 60 is X. The leg with the 30 is X square root of 3. And then the hypotenuse is 2X. So that tells me that 28 is equal to X square root of 3. So 28 is equal to X times the square root of 3. And the square root of 3 is just a number, so I can divide both sides by the square root of 3. And we would do this in our calculator. But we can also just leave it. But what I'm going to show you right now is the way that we write this exact, okay? So I have x is equal to 28 divided by the square root of 3. So what happens is we're not allowed to have a square root on the bottom of a fraction. It's just a mathematical rule that we're not allowed to do that. So how we fix it, and I'll do it up here a little bit bigger so we can follow, is I can multiply this fraction by 1, right? Anytime I multiply something by 1, it doesn't change, right? 4 times 1 is still 4. -7 times 1 is still -7. But I'm going to multiply it by 1 in the form of whatever the square root is. So in this case, it would be square root of 3 over square root of 3. This is just 1, so I'm just multiplying it by 1. So 28 times square root of 3, we just kind of smush them together and leave it. It's going to be 28 square root of 3. Square root of 3 times square root of 3 is equal to the square root of 9, and the square root of 9 is just 3. So what happens is the square roots go away, and they're gone. So this is actually the exact answer here. So that tells me, and this is like a lot, right? That tells me that x is actually equal to 28 square root of 3 over 3. Because I got rid of that square root on the bottom. So that's x. So I'm going to erase x. And I'm going to do my 28 square root of 3 over 3. Now x is this. A to b is 2 times that. So if I take my 28 square root of 3 over 3 and I multiply it by 2, 28 times 2 is 56. We get 56 square root of 3 over 3. And that's fine too. So maybe instead of x, we'll write BC, since that's what it really wants us to find. And then that tells me that length AB is equal to 56 square root of 3 over 3. That is a hard problem. That would be like a very high level problem like that. Okay, next one's not as bad. So for B, if I write the pattern of my 45, 45, 90, my two legs are x, and then my hypotenuse is x square root of 2. So that tells me that 14 equals x square root of 2. So I'm going to divide by square root of 2. And I get x is equal to 14 over square root of 2. But I can't have the square root on the bottom of a fraction. So I need to multiply by 1, and I'm going to multiply by 1 in the form of square root of 2 over square root of 2. And that gets me 14 square root of 2 over, then because I have square root of 2 times square root of 2, those square roots cancel, and I'm just left with 2. And because I can divide 14 by 2, I can divide that and just call it 7 square root of 2. And that's perfectly fine. So the length of AC is 7 square root of 2. And the length of BC is also 7 square root of 2 because they are the same, right? So a little bit harder, but still here we're just using the same pattern to find our side lengths. Okay, guys, that's it for 8.1. If you have any questions, I know that this stuff is not easy. So if you have any questions at all, make sure that you reach out, and we'll see you soon.